So on page 185 of your workbooks, we're dealing with exponential growth and decay, and we've talked about these things over the past few days kind of graphically. We're now going to focus a little more on the equations, and then on, we'll put a little more time into it tomorrow, and then on Monday we'll probably tie the two together where we go a few more equations and graphs and kind of review all that before we do a practice test on Tuesday, and most likely a test on Wednesday. That's kind of the plans right now. Okay, so in your own words, I want you to describe the meaning of exponential growth, exponential growth function, exponential decay, decay function, and we haven't talked about compound interest yet, so you may leave that one blank, but you're welcome to get a book and look it up if you want. But pictures help out, okay, equations help out. Write down whatever you can about those things, and then give yourself some room to add some notes here. And talk with your neighbors. You get 4 minutes to work on that. Okay, what do we know about exponential growth so far? Go ahead. B is greater than 1. Okay? Our base is greater than 1. Anything else? So Brendan, that's it when you're dealing with y equals ab to the x. Okay, right? B is greater than 1. We don't know anything else about it? Cool. Slopes upward from left to right. Okay, so if that was my xy axis, then our graph slopes upward. Very good. Okay, so one way to believe that is as x increases, what happens? You guys finish the statement. As x increases, what do we have? Yeah? Y increases. All right. As x increases, y increases. Bobby could have said that too. Bobby chose on. It's like, forget it. All right. So that's what we have for exponential growth. That's kind of what we've talked about. Exponential growth function is y equals ab to the x, okay, where b is greater than 1. All right. Now, I was asked this earlier about function. Remember, when we're dealing with a function or function notation, y actually changes to, what do we change y to? Man, yeah. F of x. You guys really make this difficult sometimes. Okay? All right, so we're going to rewrite it like that. Okay, remember y is the same thing as f of x. All right. Tell your neighbor what you know about decay. Thanks.
It says in your own words, not your own picture.
Okay, wrap it up, please. What do we know about decay? Annalie? It goes from right to left. So you say in a graph, when we say it goes from right to left, that means it's like going this way? Okay. All right. So it's actually falling from left to right, or it's rising from right to left. Okay. What else do we know about decay? Yeah.
It's greater than 0 and less than 1.
Good. B is greater than 0, but it's less than 1. Okay. And if you think of it in terms of a function notation, y equals abx. Remember, y is the same thing as f of x, so we'll write it like that. Okay. This is the piece that we really have to focus on there. Okay, for a lot of you, you'll just say, well, that's a fraction. It's a fraction there. Well, it has to be between 0 and 1. Okay. That's decay. As x increases, go ahead and tell your neighbor what happens with y. Good. Y decreases. Good job. Okay. So that's what we've talked about so far. Okay, we're going to hit compound interest here in a minute. We're going to be looking at these different functions here. An exponential function, now we've talked about y equals ab to the x. Well, notice in this, they've actually changed it to y equals, they have the a, but they've made b look like this thing right here. They're saying b is 1 plus r. Okay, where a is greater than 0 and r is greater than 0. That's a growth function. Okay. We have to, when we're dealing with this, notice they're saying the final amount is y. Our initial amount, or our starting point, still our y-intercept is a. Inside here, this is our rate of growth. That's the r. So we're trying to single that out. Okay, so like if you go in and if something's growing an amount, you actually have, like if you're growing by 10%, if you increase something by 10% every time, you still have the original amount. Okay, so let's say I have like a dollar. Okay, and I tell you, I'm like, well, you know what? Every time you bring that dollar back to class, so I give you it maybe on the first day, I say, every time you bring this dollar back to class, each day I will add 10% to the amount you show me. Okay, and so the first day you get $1. That's our initial amount. That would be our A value. The second day, you would bring that dollar in and I would add how much? I'd add 10 cents. I'd add 10%. Okay, so my rate of growth is what percent? 10. Okay, everyone with me on that? So this would be your first day, or actually I guess maybe day 0, okay, because I'm not giving you anything. Okay, okay. Then on the first day, I actually say, well, I'm going to give you 10%. So when you come in, I'm going to give you 10% of that. You're like, score, man, I got a dime. All right? How much money do you have now? Everyone agree with that? So after the first day, originally you had $1, and then after the first day you get $1.10. You don't just have 10 cents? Yeah? You just have 10 cents? So do I take the $1 away? I'm like, all right, Toki, you had $1, you brought it back. I'm going to take your $1 and give you a dime. Good? Yeah, I'm adding to it, right? So I'm getting what percentage of my $1 back? Though that's the amount I'm earning. I'm earning 10%, but what percent of my $1 do I get? Stay with me. TT, what percent? Yeah, I get 100% of my $1 back. Right? Why? Because you get to keep the $1. Okay? So really, what percent of my money do I have now after the first day? I have $1.10. What percent is that? Yeah, 110%. Okay, that's what's happening right here. They're saying you're taking your amount and you get the 100%. 100% as a decimal. Remember, if we change something to a percent means per 100. That's what the word percent means. It means per 100. So if I have 100%, if I have 100 per 100, 100 per 100 is, what is it? It's 1. That's where this 1 comes from right here. You get 100%. This R is the amount you're earning. So if I wrote an equation for this, I would say, well, my initial amount, what did I start with? $1. That's A. Okay, I get 100% of it back. That's that 1. Plus the rate you're getting back. What rate was I paying you? Yeah. 10%. So 10% as a decimal is 0.1. Okay, we don't have to add the 0. We can if we want, but we don't have to. Okay? And then we're multiplying that by the number of times you bring that money back. So after the first day, if you bring your $1.10 back, how much am I giving you on the next time? Okay, I've lost about 5 of you. Some of you are like, okay, I'm like talking about. You guys, it's gonna be tough this year. I'm about to hand out progress reports, and I see some of you zoning out, and some of your grades are not good. Okay, it takes you staying focused through the whole lesson. Okay, so if on the second day I give you 10% back, what are we at? Figure it out with your neighbor. On day 2, how much are you getting back?
But now it's 10% of $1.10. Not still 10% of a dollar.
So it's gonna be more. It's just not gonna be.
That's why I just said 11 cents.
No, it's gonna be.
Okay, let's wrap it up. Day 0, I was at $1. Day 1, I was at $1.10. We're growing by what percent? 10%. Day 2, what am I going to be at? How much am I adding? 11. You get 10% of this. So $1.21. Okay, everyone see that? So you get 10% of $1.10. 10% of $1.10 is 11 more cents. We're now at $1.21. In fact, if you multiply this by 1.1, our rate, that's what this thing adds up to. Okay, we should get that. In fact, day 3, how much are we at now? Yeah? Okay. Everyone figure it out on your own, real quick. What are we at now?
$1.30.
$1.31?
Yes. 32.
32?
Maybe 33.
33?
Adding 12.
Anyone
33.
checking it?
I say it's
All right, so we get 1.21 times what? What are we multiplying by every time? All right, almost made it, guys. What are we multiplying by? 1.1. And 1.1. And 1.1. What do we get? Someone's doing it out there, right? $1.33. Okay.
Actually, I said that before.
Is that rounded?
You
Is
said
it
32.
exactly 133?
You said 32.
It's 130 what?
Yeah, after I told you.
It's 133.1, okay? Or 1.331. All right? So it's not exact, but we know in our math or in our numbering system for currency, we stop at the pennies, right? We don't get that extra little 1 after that 3. Okay? And we keep going. All right. All right, the key is tell your neighbor what this 1 does. Why do we have that extra 1 right there? What is that doing in our problem here? Okay, who can give me a good explanation of what it does in your own words? I heard 2 really good ones just sitting here. Okay, Cole? Good. You always get 100% of what you had back. That's what that's doing. This is the extra you're getting. Okay? This is the extra amount. All right, what's the T stand for here? What's T the same thing as? Not Trinity, but... Okay, what's it stand for, Trinity?
The amount of times you bring your money back.
Good, the amount of times you bring your money back. And so in this table, which one's our T? X's. Okay, so it's the same thing. Time is generally your X value. But yeah, that's the amount of times you bring your money back. Okay. Any questions there? All right. Hey, Decay, real quick. I'm not going to spend as much of a big time here because this is very similar. This is on page 186. But y equals a times 1 minus r. Notice the difference between the growth and the decay one. Okay? On growth, well, I'll write it up here. On growth, your function was y equals a times 1 plus r to the t. Go ahead and tell your neighbor how they're different. All right, so what's the difference? Only one major difference. Lily?
You're subtracting instead of adding when you're
Good, you're subtracting instead of adding. Okay, so if maybe I was kind of, I don't know, meaner, and I said, well, each time you bring your dollar back, you've got to pay me 10%. I mean, you probably wouldn't bring your dollar back unless you're just generous like that. Okay, so if we went back to that example, I said, hey, each time you bring your dollar back to me, you got to give me 10% of it. You got to pay me. So day 0, you start at 1. Day 1, where are you at now? 90 cents. Okay, you lose a dime. So what's our rate of decay? How much are we going down each time? Yeah. Yeah, 0.1. We're multiplying by 0.1. Okay, that's what we're decreasing. We're losing 10% each time. Okay, that's what I end up with. So, everyone get that? All right, so right here, I'd be saying 1 minus 0.1, which is actually, what is 1 minus 0.1? Yeah? Yeah, it's 0.9. Now notice the difference here. When I say I'm multiplying by 0.1, that's the amount I am decaying. Okay? Right, excuse me, 0.9. That is my rate. My rate of decay is actually 10%. You guys see the difference there? When you're growing, this number right here is what you're growing by. When you're decaying, this is what you're decaying by. Okay? But we're multiplying by 0.9. Let me see what I'm saying there. Bit different. So if I gave you the equation y equals, I don't know, 9 times 0.75 to the power of x, what am I decaying? What's my rate of decay? Go ahead and talk about it with your neighbor. What's our rate of decay there? Okay, volunteer, what am I decaying? Annalise, what do you got? 0.75. Is that our rate of decay? Our actual rate of decay, the amount we're decreasing every time is 0.25. Okay, so decay's a little tougher because you've got to say, okay, I was at 1, that's my 100%, and how do I get to 0.75? Okay, I'm decaying this much. I'm going from 1 to 0.25. That means I'm decaying. So if I'm going from 1 to 0.75, that means I have decayed 0.25. Okay? Just like in this problem, I'm going from 1 to 0.9. I'm decaying 10. We got that? Okay, so let me give you a few examples here. If I gave you 1 plus, or excuse me, not 1 plus, let's try this again. If I gave you y equals 4 times 2 to the power of x. First, is it growth or decay? Go ahead and tell your neighbor, growth or decay? Okay, or growth, what am I growing by? Yeah? 1. Everyone agree it's 1? Tell your neighbor how you get 1.
That's because growth is supposed to be greater than 1, since it's 2.
Okay,
1 is
time's up. Hey, it's because we always start with what percent? 100%, that is 1, and then whatever we add to that is our growth. So in this case, 1 plus 1 is 2. So that's 100%, 100%. So our percent of growth, or our rate of change here is 100%. We get 100% rate of change. Everyone with me there? Okay, well let's do another one. If I have y equals, let's say 12 times 1.3 to the x. Tell your neighbor what the rate of change is.
The rate of change is
Okay, so we should be breaking this up. Someone that hasn't participated yet today, what does that break up to get 1.3? Give it a shot, Jake. Yeah, 0.3 plus what? Plus 1. And so you're saying my rate of change is 0.3. See, right? What is 0.3 as a percent? 30%. Okay, we just moved the decimal 2 like we do in our percentages. Okay, so our rate of change is 30%. Nice. Everyone with me? We figure out where we go from 1. Okay, well, let's say I have now y equals 4 times 0.85 to the x. What is my rate of change?
0.15.
Okay, so once again, where do we start? Where should we always start?
100%.
At 1. Now, are we adding or subtracting this time? Subtracting, meaning we are in decay.
Decay.
How much are we subtracting?
85.85.
0.15. So my rate of decay is 15%. How many got it? Okay. Any questions so far? It's a bit different. We're going to do one more. Okay. Y equals 2 times 0. Thank you. Y equals 2 times 0.2 to the x. Okay. JC, growth or decay? Decay. Very good. So we're decaying. We start at 1. How much are we decaying? 80. Yeah. 0.8. Okay, so this drops to 80%. 80% decay. Any questions there? All right, go ahead and turn your page, please. Take a look at page 187. Page 187. All right. Your job is to do 1 through 8. We're going to do 9 and 10 tomorrow. Okay, that's going to be our intro for tomorrow. But 1 through 8, we'll talk about compound interest tomorrow. Remember, A represents your y-intercept. It also represents your initial value, your starting amount. Okay? Here we go.